System of equations. So when they ask you to solve the system of equations, there are so many ways to solve that, because like sometimes the order of the equation would be compatible with one of the methods. Now let's talk generally, like here we have x plus 3y equal to 7 and 2x plus 5y equals to 10. So if you look at the equation, you have one of the variables, we have it like with a coefficient of 1, which make it easier for us to follow with the substitution method, as we can eliminate x alone and make it in terms of y. So like here, but to solve by substitution, we should follow, we should do some steps. Like here, x plus 3y equal to 7, we can make it x equal to 7 minus 3y. By taking 3y to the other side, then we have x alone in terms of y. And after that, that's why we call it substitution. We substitute x in the second equation, okay, by 7 minus 3y. What would happen? Would happen is 2, we open bracket for x, and we replace x by 7 minus 3y. We say 7 minus 3y. That's why we call substitution, because we substituted x by 7 minus 3y here. And we write the full equation, the second one, 2x, which is 2 into this, plus 5y equals to 10, plus 5y equals to 10. Then we simplify the brackets and we go on. 2 times 7 is equal to 14, 2 times minus 3y equal minus 6y, plus 5y equals to 10. Then minus 6y plus 5y, you get minus 1y. And here also we have 14 equals to 10. Make minus 14 here and minus 14 on the other side. So we will get minus y equal 10 minus 14 is minus 4, and then we divide by minus 1, divide by minus 1, you get y equals to 4, or multiply by minus 1, multiply by minus 1, you get y equals to 4. So after we get y, already we have x in terms of y at the top here, we did at the beginning. So we replace y by 4 in this equation. We get x equal to 7 minus 3 bracket y, we get it 4, so we replace y by 4. Then x is equal to 7 minus 3 times 4 is 12, so x is equal, 7 minus 12 is minus 5. So we got x equal to minus 5 and y equal to 4, so we put it in an order pair. We write minus 5 and we put y for 4. Now we have another expressions, another equations, like the one here. Okay, like the one here. Let's see here. This is a different case. It's already a system of equations in two variables. We have x and we have y. But the difference between this and that one, here x multiplied by a number and y multiplied by a number. Here x multiplied by another number and y multiplied by another number. So we don't have x alone to make it in terms of y to substitute. If we want to do that, we can do that, but it's going to be a little complicated. So like, because you will have a fraction, so we can make x in terms of y, but we have to divide by 4, so it's going to be a little complicated. It's better to look for something different. Let's look for something different. What's important in this system, if you look at the coefficients of x and y, let's look at them. Here we have 4, here we have 2, here we have minus 3y, and here we have plus 3y. This is an advantage for us to use. Why? Because when we add minus 3y and 3y plus 3y, you will get 0y, which means that we applied the elimination method by addition. So if we want to apply this, it's the easiest way to do is just add the two equations, add them together, you will eliminate y. Okay, so that's the case. So look at the equation, look at x and y. Do you have in both equations two numbers are the same in absolute value but opposite in sign? Like 4 and 2, no, they are not the same. 3 and 3, yes, they are the same, but each one of them with opposite sign. Here we have minus, here we have plus. So once we add them, then we can eliminate the y's. So what would happen here? 4x plus 2x is equal to 6x. Minus 3y plus 3y cancel. We get 0. Equal minus 22 plus 16 is minus 6. So 6x equal to minus 6. Look what happened. Like we eliminate y, so we have x alone. So we can get x. So divide by 6, you get x equals to minus 1, and already the solution is written here, so look at x is equal to -1, which is correct. So now, to get y, just replace x equal -1 by any one of the two equations. I prefer this because like we don't have negative sign and the numbers are a little smoother than here. So we get equation 2, so we replace 2, we put x by -1, this is -1, plus 3y equals to 16, and then 2 times -1 is -2, plus 3y equals to 16. Then add 2 both sides to eliminate 2, so we get rid of this. So 3y equals 16 plus 2 is 18. Now 3y is 18, divide by 3, you get y equal to 6. So finally you get, let's write it here, 3y equals to 18. We said divide by 3, you get y equals 18 divided by 3, 6. Of course 3 by 3 is equal to 1. So here we have y equal to 6, and here we have x equal to -1, which is the same as the solution written here. So this is one of the ways, also like one of the, I'm not saying it's a different way, but I'm saying that it's a different procedure because we have advantage. We use the advantage that we get in this question. Here we have -3, here we have +3, so we use that advantage to get rid of y. Now in the second equation, let me just put this aside. Okay, and let's get that question here. So in this question, if you look, there is something similar to the previous question, but if we look at the numbers, here we have 6x, here we have 4x, here we have -5y, and here we have -5y. So which means that we have the same number. So if we add them together, look what would happen. We get 6x plus 4x is 10x, but here -5y, you get -10y. So which means that we are still stuck with x and y, so we cannot solve it. Like we didn't eliminate any one of them. So it's better to do what? It's better to make them opposite signs. Here we have -5y. How do we change one of them to be the opposite of the other? So one of the things which is one of the rules in math, you can multiply the equation, okay, by the same number, but you have to multiply the whole equation, the left side and the right side. So if we multiply, we need -5 to be +5 to be opposite to this. So what do we need to multiply by? We multiply by -1. So if we multiply by -1, what would happen? Let's write the second equation. -1 times 4, you get -4x. -1 times -5, you get +5y. And -1 times -12 is equal to +12. Look what happened. Let's write the first equation. You get 6x minus 5y equals to -8. Let's compare them. So we have -5y, we have +5y, then we have the opposite signs, so we can eliminate it. Now what we do addition, adding, same as we did previous question. After we multiply by -1 the whole equation. So 6 plus -4x, you get 2x. Now -5 plus 5 eliminated, cancel, and then -8 plus 12 you get 4. Then 2x is equal to 4, which is a simple equation and one unknown. Then divide by 2, you can get x equals 4 divided by 2 is equal to 2. Now we got x equal to 2, so we replace it in one of the equations. Instead of x, we can get y. Let's use the second equation. Let's say 4x minus 5y equals to -12. Then replace x equal to, in this equation you get 4 into 2 minus 5y equal -12. So 4 times 2 is 8, minus 5y is equal -12. Now we need to eliminate 8, so we take it to the other side. We do -8 minus 8, then minus 5y equals -12, and -8 you get -20. Divide by -5 both sides, -5, then y is equal to, negative by negative is positive, 20 divided by 5 is 4. So we have x equal to and y equal to 4, which is matching the answer that we have here. Now in these two questions we don't have same numbers or opposite numbers in two equations, but we have an advantage here also, which is like one of the numbers could be the other. Like, can you make 3 6? Yes. Can you make 6 8? No. Like, I'm talking about the coefficients of the variables. Like 3 could be done 6 by multiply by 2, and since minus 6 already the opposite of the sign here, so we multiply only by 2 to make it 6, so they are opposite. Here we have minus 6, here we have 6. So we look at the numbers as we mentioned here. So we take the second equation and we multiply it by 2, then we get 6w, and here we have minus 6w. Remember, the previous questions, they were the same, and if they are the same numbers and not opposite signs, we can multiply by -1 to make them opposite so that we can eliminate. But in this question, already the number is different, but we can make one of them the other. So if you multiply by 2, let's write the first equation. We get minus 6w minus 8z equals to minus 44. And here 2 times 3 is 6w, 2 times minus 6 is 12z, 2 times 36 is equal to 72. Okay, so now after finishing we add the two equations, minus 6w plus 6w cancel. So remember that you can control the negative sign and the plus sign, so you can control, like if we have minus 3w, so we multiply by minus 2 so that we can make it plus 6w. So it's up to you. The most important thing that we make them opposite signs so that you can add them and get them 0. So you are the manager here, so you can control. So don't be don't be scared. Like, don't think that the problem is controlling you. No, you are the controller of the problem. You can control it and you can do whatever you want, but you have to follow the rules of math. When you multiply by something on the first side of the equation, you have to multiply the second side of the equation by the same number. Remember that. So now minus 6w plus 6w is equal to 0, so this cancel. Now minus 8w plus minus 8z plus 12z, you get 4z equals minus 44 plus 72 is equal to I don't know, let's try it. Let's say 72 minus 44, so you get, it's 6, 12 minus 4, 8, and 6 minus 4, 2, so it's 28. So you get 28, and because plus 72 and this is minus 44, 72 is bigger than 44 in absolute value, so it has the sign plus, so we get plus sign here. So the bigger number is in positive. Okay, so divide by 4, divide by 4, so you get z is equal to 7. So after getting z equal to 7, look, this is z equal to 7. Remember, w is the first, z is the second, w first, z is second. This is w, this is z. So z equal to 7. So we replace z equal to 7 in one of the equations to get w. So let's replace it in the second equation. Let's clean here. Okay. And now we write 3w plus 6z equal to 36. Now replace z by 7. So write 3w plus 6 into 7 equal to 36. Then 3w plus 6 times 7, 42 equal to 36, minus 42 here, so you get 3w equal, cancel, minus and plus cancel, you get 36 minus 42, you get minus 6, and then divide by 3, you get w equal to minus 2. So as you can see here, w is equal to minus 2, so then this would be the answer. So we have minus 2 and 7, the answer of this equation. This equation is similar, you know, but this would suggest the other choice, like I mentioned here, when they have same sign. So let me show you this one, and here let's bring it here better. Okay, give space, let's clean here more. Okay, yeah, let's talk about that. Now here we have 6x minus 4y equals to 30, 12x plus 5y equals to minus 18. What is the advantage here? As we mentioned, that 6 could be done 12 by multiplying 6 by 2. So if you multiply 6 by 2, you get 12. But the 12 and the 12 gives 24. So we need them to be opposite. So either you multiply 6 by 2, you get a 12, and you multiply this equation by minus 1, so you get 12 and minus 12, or you multiply the first equation by minus 2, okay, in one shot, then you get the opposite of the numbers. So if we multiply the first equation by minus 2, let's take the number 24 here, okay, and let's make a space. If we multiply the whole equation here by minus 2, what would happen? This becomes minus 12. So you get minus 12x. And here what do we have? 12x. So they match together, so we can eliminate them and we can get them 0. Get their sum 0. So, but we cannot multiply only this. We have to multiply this, and we have to multiply the other one. So minus 2 times minus 4, you get plus 8y equals minus 2 times 30 is minus 60. Let's write the second equation as it is. 12x plus 5y equals to minus 18. Now we add both equations together. So 12 and minus 12, you get 0. 8 plus 5 is 13y equals minus 60, and minus 18, you get minus 78. Right? Okay. Minus 60 and minus 18, minus 78. Minus 78, let's divide by 13, divide by 13. So you get y equal, so 6 times 13 equal to 78, I guess. 13 times 6 times 3, 18. 6 times 6 and 1, 7. Yes, that's correct. But don't forget we have minus signs, so we write minus 6. So y equals to minus 6, and it matches here, minus 6. Now we need to find the second one. The second one is x. We got y equal to minus 6. We need x, so we replace it in the first equation or in the second equation. It's up to you. So you have to decide. And if you replace it in each, any of the equation, you will get the same answer for y, for x. Or you get x equal to 1 probably. Let's try to get 1. So we write 6x minus 4y equals to 30. So we have 6x minus 4 into y is minus 6, so we have minus 6 equals to 30. Then 6x minus 4 times minus 6 equals plus 24 equals to 30. So minus 24 minus 24, you get 6x is equal, this is cancel, right? Okay, 30 minus 24 is equal to 6. Divide by 6, divide by 6, x is equal to 1. Wahoo, that's 1, perfect. So we got 1 minus 6, so this would be the answer of the equation. So we spoke about the different cases, the advantages of something. We have it like as an advantage in the equation. Now we have another one which we don't have advantage, so we have to follow the proper procedure, which if you followed here or in the previous questions, you can get the same answer. But here we don't have advantage. Let me show you that that's a normal problem. Like if you look at the question like here, so if you want to look at the advantage in x or advantage in y, or if you see that there's substitution, you will not find anything. Like 5 couldn't be 8, 8 couldn't be 5, 2 couldn't be 3, 3 couldn't be 2. So you cannot change any of them. And also if you want to use substitution, you will be getting like a complicated expression. So you cannot find, let's say, a in terms of b easily, like a equals something, b plus something. Like it's going to be something divided by, so which is not a simplest form, not a simple form. So it's better to look at that. We follow the regular procedure. The regular procedure is to make this number, like to make them both are the same. So we look at this number, we multiply it up. We look at this number, we multiply it down. So that is the way that we can do. So if we cannot make one of them the other, so we try to make them both the same number. We look at their multiple, like their multiple is 5 times 8, 40. So we multiply each equation by the number that make this the multiple, the common, we say the least common multiple. We can do it in different ways more, so but the one that I'm suggesting here is we look at 5 here, we multiply it up, and we look at 8 here, we multiply it down in the second equation. So here you get 8 times 5, 40, and here 5 times 8, 40. Now you ask me, why do we have to do it for A? No, we can do it for B also. Okay, so we look at them, which one of them is the opposite. So instead of having the multiplication by negative or positive, so what I suggest here, since we have here negative and here we have positive, so already we have them in the opposite signs, so we look at their coefficients. So 3 and 2, so we multiply here by 3 and we multiply here by 2. Why did I multiply? Because 3 is here, so we multiply it here. 2 is here, we multiply it up. So when you multiply 2 by 3 you get 6, and when you multiply by 3 you get 6. And already we have opposite signs, so when you add them you get 0. Otherwise you have to multiply here, as we mentioned before, 5 and 8. We multiply one of them later by negative signs so that we can subtract. So if you multiply 2 by 8 you get 16a, multiply 2 by minus 3 you get minus 6b, you multiply 2 by minus 11 is minus 22. Now, common mistake, some students, they do what? They do multiply 2 by 8 and they leave it, they do not multiply it by 3b. Another common mistake, which is the students, they multiply the left side of the equation, but they forget to multiply the right side, so they don't multiply 2 by minus 11. This is a common mistake, so make sure that to multiply the number by the whole equation. Now, for here, 3 times 5a you get 15a, 3 times 2 which is 6b, and 3 by minus 3 you get minus 9. And then after that, when you add them together, this would be cancelled. 16a plus 15a you get 31a equals minus 22, and minus 9 you get also minus 31. Wow, that's nice. Divide by 31, divide by 31, you get a is equal to minus 1, which is here. So that's a, so that's correct. So and after we get a, so we need to substitute a equal minus 1 in the one of the equations. So I will use this. Let's say in equation 2, 5a plus 2b equals to minus 3. So replace a by minus 1, you get 5 into minus 1 plus 2b equals to minus 3. Then we can get minus 5 plus 2b equals to minus 3. So plus 5 and plus 5 each side of the equation, you get 2b is equal to 2. Divide by 2, divide by 2, you get b equals to 1, and that's everything. So minus 1 and 1 is the solution. It's written already here, minus 1 and 1, and those are the most cases except the consistent and dependent, which is the case that we have infinite number of solutions. So those cases are special cases. Let me give you an example. So in these examples, if you see here, if we want to apply the elimination by multiplying, let's say, one of them, we have an advantage here, like 7 becomes 14, but the problem is also here the number is becomes like 1 becomes 2. In this equation 4 becomes 8 and 3 becomes 6. So let's try and see what would happen. So if you multiply the first equation by 2, so what you get 14x, 2y equals to 8. But here we have plus 14, and you multiply by 2 you get plus 14, so we need to get different signs, so we add the minus sign here. So then you get minus 14 and 14, so it would be cancelled. So minus 2 times 7 is minus 14x. Minus 2 by y equal minus 2y equals minus 2 by 4 is minus 8. So what do we have here? We have 14x plus 2y equals minus 21. Now if you look, we can eliminate. Let's add them. So when you add them you get 0x. Oh my god, when you add here you get 0y also, equals to minus 8 minus 21 you get minus 29. So if you look at the left side of the equation, if you add them all together you get 0 equals to minus 29. Is that possible? Is that logical? There's no logic to say that 0 equals to minus 29, so that's impossible. So we say impossible, that we say no solution in this case. So there will be no solution for this system of equation because it leads us to a non-logical equation at the end. Non-logical statement. 0 does not equal to minus 29. That's impossible. Let's look at the other equation. In the other system, 4 could be 8 and 3 could be 6. So if you multiply 4 by 2 you get 8, and unfortunately look at here, 2 times 3 also you get 6. So and 2 times 10 equal to 20. So let's see what would happen, but we need to make them like opposite signs. So if you multiply by minus 2, so you get minus 8, and we have plus 8, so we can eliminate. So let's see what would happen. Minus 2 times 4 is minus 8x. Minus 2 times minus 3, you get plus 6y. Minus 2 times minus 10, you get plus 20. And here we have 8x minus 6y equals to minus 20. The second equation I'm writing here. And this one, by multiplying by minus 2, you get this. So if we add them together, what do you get? You get 0x plus 0y equals to 0. That's true. You know, that's a true statement. So when you have 0x plus 0y equals to 0, that's a true statement. Then we can say wherever the system x and y, okay, so we have many solutions. But here we call it dependent variables. So x and y, we cannot say x could be any value and y could be any value. No, there are order pairs for x and y, okay, like matching together, okay, dependent on each other. So if you substitute it in the equation, it would work. Okay, so let me show you an example here. So this is an example, like let me show you, like at x equal to 2, y equals to 6. So this order pair satisfies both equations. Let's try x equal to y equals 6. 4 times 2, 8. 3 times 6, 18. 8 minus 18 is minus 10, and if you replace it here, you get minus 20. So 5, 10. So if you replace 4 times 5, you get 20, and minus 3 times 10, minus 30. 20 minus 30, you get minus 10, and if you replace it here, also it works. And if you replace 8, 14, also work for both equations. So which means that we have more than one solution, okay, which means that we have 3. This is which I showed you 3, but there will be many, and there will be infinite number of solutions that satisfy both equations. And I'm not in the process to show you how do we get it. So if we there's a process how do we get these solutions, but here only just to mention that this system is we call it, it has many solutions. It's consistent, it has many solutions, but it's dependent. Independent when we have one solution, but dependent when we have many solutions. So in this case, this system is consistent and dependent. And we will talk later, like in later videos, about different types. And see you later. Thank you guys.